Welcome back. Today we're going to be solving problems relating to conservation of energy. So let's start with this problem. A 65 kilogram girl, and before I go further, I will write down each variable that we're given. So this is mass, which is usually denoted with a little m, is 65 kilograms. Is running with a speed of 2.5 meters per second. In conservation of energy questions, this is usually going to be the velocity, although velocity is a vector and it usually should have a direction, like 2.5 meters per second north or to the right. There's no direction, but it doesn't matter in these types of questions anyway. You will still count this as a velocity, although yes, technically it would be a speed because there's no direction. How much kinetic energy does she have? The equation for kinetic energy is 1/2 times mass times velocity squared. So we have 1/2 times 65 times 2.5 squared, which is 203.125. The units of energy will be in joules, as long as this is kilograms and this is meters per second. And this would be the final answer for kinetic energy. So the next part of the question is where we will actually use conservation of energy. This was just finding kinetic energy, which is just plugging in the numbers. Here we will have to use the concept of conservation of energy. She grabs onto a rope that is hanging from the ceiling and swings from the end of the rope. How high off the ground will she swing? If we make a picture of this, so initially she's running, and then she grabs onto this rope, and once she grabs onto the rope, she's going to be swinging on the rope. She's holding onto it like this. So this is the point where she will, grab onto the rope, then she swings. You always want to draw a picture and label your 2 points that you're doing the conservation of energy between. These are usually points you're given information about. Our first point we were given the information for is that she's just running. And our second point is when she's swinging from the end of the rope. We don't know how high up she goes, but this would be the second point. We can ignore the part where she actually grabs the rope, but the 2 main points we want to look at in her journey are here and here. The reason for this is because the conservation of energy will work between 2 points only in an object's motion, in this case, the girl. So usually when we talk about different types of energies for a conservation of energy, you can have kinetic energy. This is usually EK. You can have potential energy, or this is called gravitational potential energy, or just gravitational energy. You might see it as EP or EG, it's the same. And you might also see thermal energy, which is caused when you have friction, in which case we don't, but you might see an ETH. And all of these energies combined make up something called mechanical energy, or EM. Now, conservation of energy says that at any 2 points in an item's motion, so we selected points 1 and 2 here, the total mechanical energy will be constant. So let's just say we have 100 joules of energy here. You will also have 100 joules of energy at the end of her journey. You just don't know how it's split between the 3 types of energies. You might have more or less of one of these energies. So you could have 50 joules here, 10 joules here, and 40 joules here in the beginning. And by the end, you might have 60 joules here, 0 here, and 40 here. You don't know. So this question doesn't talk about friction at all, so we can ignore thermal energy. Now we have to look at, when does an object have kinetic energy? It's going to be when they're moving. If they're moving at all, it's going to have some kind of kinetic energy. Potential energy is when you have a height. And what's important when you do these kind of questions is that you define your 0 height. So for us, we're going to say the ground is when height is equal to 0. Let's say someone is parachuting off of a plane. We might say that their initial height would be 0 here, and once they reach the ground, they will have traveled however much of a distance. So the height could be starting at the top, it could be starting at the bottom, but you do have to define the height in these questions, otherwise you won't be able to see what the potential energy would be relative to a height of 0. So for us, this person is a bit off the ground here. They would be on the ground when they're running, so the height here would be 0. in the beginning, because she's running, she will have only kinetic energy, no potential energy, because the height is 0. At this point, because it says how high off the ground will she swing, that means they are asking how high can she get at the very maximum point. If you notice, when you throw a ball, at the very, very top, it pauses for a split second before it comes back down. It's the same thing here. She's going to start swinging, and at some point she will reach her maximum. She'll pause for a split second, which you might not even notice, but in physics terms, maximum height, how high off the ground will she swing, in this case they are asking for maximum height, usually means that the velocity is 0 because she's paused for that split second at the maximum. So we're going to assume then that we have no kinetic energy at the end, and if we did include kinetic energy, assuming she was swinging as well as having a height, we wouldn't be able to solve it because we don't have her final kinetic energy anyways. So this assumption would make the most sense. So to set up the equation, we now have the initial mechanical energy equals the final mechanical energy. So this is the initial energy that she has at this point. This would be the final energy. And initially she only has kinetic energy, and at the end she only has potential energy. And now you just expand those equations. So from the first part of the question, we discussed this is the equation for kinetic energy. So we can put a VI here because this is the initial velocity. And the equation for the gravitational potential, we didn't discuss this earlier. It's mgh, so mass in kilograms times g, which is the gravitational constant. It's always 9.8 meters per second squared, times height in meters. And now we just plug everything in. So we have 1/2 times the mass of 65 times 2.5 squared. And we already got that number here. It's 203.125 equals mass of 65 times 9.8 times the height, which is what we're looking for. Now we can simplify this, which is 637 times h. Now in order to simplify, we always bring the number that's being multiplied to the other side and divide. So when we divide this by 637, we get a height of 0.318 meters. And that's the final answer. Thanks for tuning in.